So I want to talk a little bit more about normal force. Normal force is the force of a flat surface that acts on an object. So you need to be touching a flat surface. I can be touching the wall, for example. As I push on the wall pushes on me. It exerts a normal force out in the direction towards the camera. So it's a flat surface. Now, if we look at a block either sliding along the floor or at rest, it doesn't really matter. Regardless of how it's moving horizontally, vertically it's got a weight downwards, F sub g, and it's got a normal force up, and those have to be balanced. Even if it's accelerating to the right or the left, it's not going to be accelerating off the table. It can only be accelerating, well, it will only likely be accelerating in one of those directions. So on a flat surface like this, oftentimes your normal force is equal to your weight. And your weight is mg on a flat surface. Now that's not always the case, but that is often the case. There are times when it might not be equal to your weight. So for example, let's say that you have a block like this that has, it's a 20 Newton block, right? And you know that it has a normal force. But let's say in addition to the weight, maybe you are pushing down on the block with another 10 newtons of force. I can take a block and I can push down on it, right? It's still not going to go down into the table. The more I push, it doesn't matter how hard I push, it's still not going to go into the table. I'm not strong enough to push that block all the way into the table. So it turns out that this has got to be balanced vertically up and down. So your normal force is going to equal the weight plus whatever you're applying. So in this case, your normal force has got to be 30 newtons. If I pushed with more force than that, let's say I pushed with 70 newtons, the block's still not accelerating into the ground, so your normal force has still got to balance out with the downward force. 70 plus 20 down means that you have to have 90 up. 90 down, 90 up. Most of the time it's going to be the first situation, but you can run across places like this. You also see sometimes normal forces on inclines. And so imagine this, an inclined surface. And the normal force on the inclined surface looks a little bit like this. It is perpendicular to the surface. We have a weight going down, F sub g, and it's got a normal force going out like that. Maybe it has friction. I haven't drawn friction in here. Now it turns out that this block is going to only be sliding along the top of the surface like that. Which means that it's not going to be equal and opposite to the weight. Something else is going to balance it out. And it turns out that we're going to get into vector components again. So if that's the weight, that weight can actually be resolved into two components. One that's perpendicular to the surface and one that's parallel to the surface, such that this vector plus this vector equals the resultant weight. And it turns out that this one is just your weight times the sine of your angle here. And this is your weight F sub g times the cosine of the angle. So in this case, your normal force has got to balance with this other component here. And maybe this F sub g sine theta is what's actually carrying it down the incline. So your normal force is equal and opposite to F sub g cosine theta, meaning your weight mg times cosine theta. You're not likely to see that all that often on a Regents exam, but I think it's very important to know, and it could come up, just to understand how forces balance out even when you're not on a flat surface. Thank you very much for watching.